Alright, this video is going to review a couple things. The first thing that we're going to review is how to find asymptotes for rational functions. And the second thing we're going to review is how to find limits at infinity. So if you are looking for a horizontal asymptote, you will find those when you can find the limit as x approaches positive infinity and when you look for the limit as x approaches negative infinity. And when you write your horizontal asymptote, it's always in the form y equals some number. When you look for a vertical asymptote, those are found where the denominator of the rational function equals 0, provided that that value that you found is not a whole. And vertical asymptotes are written in the form x equals a number. And then last is finding a slant asymptote, and some schools call these slant asymptotes, some schools call these oblique asymptotes. So whichever you have heard based on your teachers in the past. There is a slant asymptote or an oblique asymptote if the numerator is exactly 1 degree higher than the denominator. And to find the slant asymptote, we would use polynomial long division. And the equation of these lines are going to be y equals mx plus b form. And that is what you will get when you use polynomial long division. You will not have to complete the entire polynomial long division process. You will just do it long enough to get an equation that is y equals mx plus b. Alright, so here is our example problem. We are going to find the asymptotes for the function y equals x squared plus 1 divided by 3x squared minus 1. So for the horizontal asymptote, we're going to say the limit as x approaches infinity of x squared plus 1 divided by 3x squared minus 1. And if we think about what would happen if we plug in infinity, this plus 1 on the end here and that minus 1 on the end there, those would do absolutely nothing. So this infinity squared number and this infinity squared number on the bottom, you can think of those as being the same value divided by itself, and so essentially those would cancel out. And what we would be left with is the 1 on the top that is the coefficient to the x squared, and the 3 on the bottom that is the coefficient to the other x squared. So we would say that the limit here is 1/3. Now if I look at the limit as x approaches negative infinity for the same function, it will not change our outcome at all because we are squaring that number. So it doesn't matter if it's positive squared or negative squared, it's going to give us the same value. And again, I'm going to get 1/3. So my conclusion from this is that there's only one horizontal asymptote, and that that horizontal asymptote is found at y equals 1/3. All right, next we'll look at the vertical asymptote. And the vertical asymptote comes from where the denominator equals 0, so long as those values are not considered to be wholes. And if you guys recall, wholes are factors that cancel out on the top and the bottom, so you can see the same factor on the top and the bottom. And in this problem, since x squared plus 1 that's not the difference of squares, that's not actually factorable, and so there cannot be a factor that would cancel. So in this case, we're just going to go ahead and solve for the denominator. And there are two ways of solving this, and I'm going to go through both of them because I want you guys to see maybe how you could factor this. So most of you guys would probably solve just by adding the 1 over. So 3x squared equals 1, and then you would divide the 3 over and get x squared equals 1/3. And then you would square root that. So we have the square root of 1/3, and hopefully you would recognize that anytime you square root something, you should put plus or minus in the front, and you could get your two values that way. The other way of doing this problem is to think of this as being difference of squares. So hang with me because I know that 3 is not a perfect square. So when you do the difference of squares, we would put a plus in one and a minus in the other, and 1, I know I can take the square root of that, that's 1 and 1. And x squared, I can take the square root of that, that's x and x. But I can't take the square root of 3 without getting a decimal, so I'm just going to write square root 3 and square root 3. And so that makes this first factor equal to negative 1 over square root 3. And the second factor equals positive 1 over square root 3. And that's actually exactly the same as if I fixed this and kind of split it up so I have square root 1 on the top and square root 3 on the bottom, because the square root of 1 is just 1. So these two answers are the same, so that means you can either set it equal, whenever you see a problem like this, you can actually do difference of squares even if the number is not a perfect square. It still works to factor. Alright, so those are our vertical asymptotes, right there. And then for this one, the degree of the numerator and the degree of the denominator were equal, and so we would say for the slant asymptote or oblique asymptote, there's none. All right, so we're going to do one more of these just so that you can see one that has a slant asymptote. So here's the next example. The instructions are the same, but this one's going to be x squared plus 1 divided by x plus 1. So first, if you start looking for a horizontal asymptote, you're going to find that the limit as x approaches infinity of x squared plus 1 divided by x plus 1, if we were to plug these in, positive infinity squared is a huge number. The ones are so small that they wouldn't even make a dent into infinity. So infinity squared is a huge number. Infinity is a less huge number. So infinity squared divided by infinity is still just infinity. If we were to look at the limit as x approaches negative infinity, again, the ones aren't going to matter, so negative infinity squared gives us a positive, super big number. Negative infinity down here gives us a less big number that happens to be negative, and then positive divided by negative is going to give us a negative answer, and a huge number divided by a less big number is still huge. So these tell us, if we hadn't already figured out that the degree on the top is exactly 1 bigger than the degree on the bottom, these tell us that there is no horizontal asymptote, because the limit for both of these technically does not exist. Both of these are unbound. So we're going to go ahead and find that slant asymptote, and the slant asymptote you find by doing polynomial long division. So we are going to take x squared plus 1, and when you do polynomial long division, you can't skip any powers, so I'm going to say x squared plus 0x plus 1. We're going to take that and divide it by x plus 1. Alright, so in polynomial long division, my first question is I ask myself, x multiplied by what is x squared? And the answer is x. And then after that, we take the top number and we multiply it by the things in the front. So x multiplied by x is x squared. X multiplied by 1 is 1x. And then we draw the line underneath. And when we draw the line underneath, we change the sign because we are subtracting these things. So x squared minus x squared is 0. 0x minus 1x is negative 1x. And so now I'm going to take negative 1x, and I'm going to, well, we have to drop down this number. And now with this, I'm going to say x multiplied by what gives me negative 1x, and the answer to that is -1. And if you guys remember what I said on the previous page of notes, I said that when you look for the slant asymptote, you're only looking for the equation to be y equals mx plus b. So once you have y equals mx plus b, you're done. So we do not need to finish the problem. We have found the answer already. So the slant asymptote here would be y equals x minus 1. All right, so real quick, we want to practice just a few more limits at infinity because it's been a while and you might run into some of these. So we're going to find each limit. So the first one is going to be the limit as x approaches negative infinity for 3x squared plus x minus 2 divided by 5x to the third plus 4x plus 1. So when we do this problem, plugging infinity into x to the third and x squared is going to be so huge that the rest of the problem really doesn't even matter. So I don't even consider looking at those. So 3 multiplied by negative infinity squared, negative infinity times negative infinity is going to be some really large positive number. And then 5 multiplied by negative infinity cubed, if we do negative infinity times negative infinity times negative infinity, the number is even bigger on the bottom, but the answer is going to be negative. So we're going to say that here we have 0 divided by a huge number divided by negative infinity, and overall that's our conclusion, is that we've got 0. So if you guys remember, anytime we have a number on the bottom that is much larger than the number on the top, we say that that's approximating 0. And maybe this was a confusing way to write it, because let's go ahead and say we had infinity squared on the top and negative infinity to the third on the bottom, and the bottom was just much, much larger than the top, and that's why we said it equals 0. It's kind of like the idea of having 1 divided by 5 million. That is basically 0, even though you're not quite there. Okay, the next one, we're going to say the limit as x approaches positive infinity this time. And here we are looking at 2x squared plus 1 divided by 3x minus 5. So here, again, the numbers on the end are so small, they're not even going to matter. And if you look at this one, the square root of x squared is just plain old x. So when I think about this, when I'm comparing the degree of the bottom with the degree of the top, I actually notice that these two are identical. So if I think about this in terms of the infinities being plugged in, infinity squared would be positive, a very large positive number, but when I square root it, I just get infinity. And then on the bottom, I had a positive infinity there as well. So this positive infinity on the top and positive infinity on the bottom are going to cancel each other out, and I'm going to be left with square root of 2 divided by 3. Now, we want to look to see how this is different if we look at the limit as x is approaching negative infinity for the exact same problem. So here again, the 1 and the negative 5 are so small, they don't even make a difference to us. If I do negative infinity squared, I get a very large positive number. If I plug negative infinity here, it's still negative infinity. So now the value of my large number is about the same, but the signs are opposite. So that's going to mean that when I divide them, I should get a negative answer. And then if I look at the coefficients, I've got root 2 on the top and 3 on the bottom.